For all others, screen is visible.
Yes, sir.
Yes, sir.
Then
Yes,
you
sir.
rejoin.
Yes, sir.
You rejoin then. Understood how I got this formula? All of you understood how I got this formula? You can directly remember this formula instead of that whole calculation and all. Okay?
Sir,
Yes.
sir, can you please explain the second step? I got disconnected, sir.
I simply kept the values of H, E, mass, and 2. Then I have solved all these things and at last I got this 150. So do not need to solve it all the time. You can simply remember this formula for electron. Padma.
Yes, sir. Got it.
Okay. If I go for proton, what will change? If I go for proton, what will change?
Mass.
क्या चेंज होगा? मास ओनली विल चेंज. चार्ज तो सेम ही रहता है. So it will be 0.286 root V angstrom. Okay. For proton, this will be the formula. Any doubt to anyone in this? Am I audible?
So please come back.
Am I audible?
Yes, sir.
Screen is
Yes, sir.
Yes,
visible.
sir.
Done. Can we proceed now? If I go for alpha particle, what will change?
Mass.
Only mass. Only mass,
The
Padma.
charge.
Charge भी change हो जाएगा.
Charge.
Helium has
Not
+2 charge. Proton has +1 charge. Right?
yes, sir.
Didn't I tell you this? All of you know this. Helium has alpha particle has double the charge of proton and 4 times the mass of proton. I gave you this in the some basic particles or
Yes,
subatomic
sir.
particles. So there it will become this. Okay.
Sir,
Yes.
what is alpha particle?
Alpha particle is helium nuclei. All of you know this? All of you know this? Okay, Sanya.
So what is its application?
Its application is there in the, just wait. Any problem with the screen? All of you can see the screen?
Yes, sir.
Yes, sir.
Okay. See, its application is there. First, you can see we have produced neutron with this alpha particle only. if you remember, that we have generated neutron with this only. When helium was bombarded on beryllium, then we got alpha particle. Sorry, we got neutron. Okay, this was done by Chadwick. This is the application you can say. Second, these alpha particles are used in the nuclear chemistry. न्यूक्लियर केमिस्ट्री में यूज होते हैं टू कन्वर्ट वन रेडियोएक्टिव एलिमेंट इनटू अदर. ओके सानिया, अब न्यूक्लियर केमिस्ट्री जो है वो 12th क्लास में है. एज ऑफ नाउ यू कैन सिंपली से दैट alpha particles are used in nuclear chemistry to convert one element into other. Okay, how it is generated, how they are used, that all we have in the nuclear chemistry 12th class. As of now, just consider it as the alpha particle only. All of you understood this now?
Thank you, sir.
Yes, sir. All of you understood this now? For example, question can be, yes, Aradhya, that is called nuclear chemistry or nuclear reactions. Calculate the de Broglie wavelength of an electron when it is accelerated with the potential of 50 volts. Three root 50. Lambda is 150 upon root 50 angstrom. That will be 150 by 7 angstrom. So 21.4 angstrom nearly. Okay.
Sir,
Yes.
what about 3 root 50?
3 root 50. So root 50 के form में you won't get it. You have to solve it. Root 50 क्या होता है? रूट 50 को हम 7 नहीं लिख सकते. Nearly. Can we write root 50 as 7? Sania.
Yes, sir.
है ना, तो इस तरह से सॉल्व करो. That is better.
लेकिन सर अगर ऐसा किया तो भी चलेगा.
डिपेंड्स अपॉन द ऑप्शंस. मैक्सिमम टाइम 95%, 98% आपको इसमें आंसर मिल जाएगा.
Okay, sir.
ठीक है, आप बिल्कुल परेशान मत हो उसके लिए. All of you understand because you won't be having the calculators. कैलकुलेटर तो होंगे नहीं, आपको उसमें शार्प टाइम लगा के मिनिमम टाइम लगा के आपको बेस्ट आंसर देना है. सो दिस इज द वे. All of you understood this?
Sir, please scroll up.
All of you understood this? All of you understood this?
Yes, sir.
Can I give you next question now? Sanya, done?
Yes, sir.
Sure. Find the ratio of wavelength of A and B if kinetic energy of A is 9 times the kinetic energy of B. Kinetic energy of A is 300 times or 300% more than that of B. Kinetic energy of A is 200% of B. Solve this. Pranil, please mute your mic. Who's this? Anyone done? Okay, Pranil, sorry. Lambda is equals to h upon root 2 m into kinetic energy. That means lambda is inversely proportional to root of kinetic energy. That means lambda 1 by lambda 2 is equals to kinetic energy of 2 divided by kinetic energy of 1 per root. Any doubt till here? Any doubt till here? Am I audible?
Yes, sir.
Very good, Sakshi. Amod, very nice. All of you understood this? I have got only two answers. What about others? They have not got the answer? Am I audible? Or there is some issue? Am I audible?
Yes, sir.
None of you have given answer. Only two answers I've got. Or it's not loading. Okay, now answers are here. Okay. Second, A, kinetic energy of A is 300% more than that of B. So kinetic energy, if kinetic energy of B is X, then kinetic energy of A will be 4x, right? Now we can apply Z of A divided by Z of B, or lambda of A divided by lambda of B. It will be 4x upon x, that will be 2 is to 1. Third, kinetic energy of A is 200 times that of B. If kinetic energy of B is x, then kinetic energy of A
The screen is not visible, sir.
The screen is not visible, sir.
is showing Teams logo.
The screen is not visible.
So the team CPK is open.
sir.
Hello, am I audible?
Yes, sir.
Yes, sir.
Yes, sir.
Screen is visible.
Yes, sir.
Yes, sir.
All of you done this much?
So show the second part.
Just wait.
Yes, sir.
Sir, can you show the second question?
Yes, yes, just wait. Yeah, it's visible.
So in the second one, it should be root of x upon 4x, right?
B. Okay, okay. B is X and A is 4X. Yes, it should be 1:2. Yes, Madhura. All of you understood? All of you understood this?
Yes, ma'am. So could you please scroll up a bit? My internet is gone.
So,
Yes.
can we solve it without using x?
You're done, sir.
Without using X.
Yeah, in a different way.
Take any number.
Yeah, I've just taken 100.
Okay.
We
What is
can
the
do
300?
that.
Very. We can do that way also, no? X can be 100 also. X can be anything.
Okay, sir.
You want me to do it?
No, sir.
Okay. Take 1 or take X. Take those numbers which can easily get cancelled out. That will be better. And on relation between Bohr model and de Broglie concept. Okay. So Bohr said that if this is the nucleus, electron is moving like this. Electron is moving like this. Okay. This is what the Bohr model, right? Am I audible?
Yes, sir.
Yes, sir.
Yes, sir.
Screen is visible.
Yes, sir.
Mm,
Yes, sir.
mm.
Okay. So this was the Bohr model. De Broglie just said that everything is correct, but electron is moving in a wave manner. Electron is moving in a wave manner on this circular path only. Electron is moving in a wave manner. How? Like this. Any doubt in this? Any doubt in this? Am I audible?
Yes, sir.
Any doubt in
Yes, sir.
this? This is the wavelength. Okay. I can make it better. But the basic idea will remain same. Yes, his concept was true, but we will see in Heisenberg principle that it is wrong. Okay, till now, de Broglie concept is also true, and the Bohr concept is also true. Sanya, sir, both
Sir,
Bohr. Yes, yes, bolo.
sir, can electron move in wave?
That's what we are doing. Na, in this concept, that electron has wave
It
nature
can
as well as
only move
particle nature.
circular. It could
It is
only
moving
move.
in. It is moving in a circular form only, but it is moving. It is not linearly moving. It is moving in a wave manner.
Okay,
Okay,
sir.
that
Okay,
that is the only thing given by this concept.
understood, sir.
Yeah, what Yash is saying. But Bohr model represents the wave nature of electron. Yes, Yash. He just said that electron is moving. That was saying in the Bohr model, it was like electron is moving in a linear path, right? But this theory said that electron has a wave nature, like it there is a relation between wave nature and the particle nature. That is the only thing. Bohr model represents the same thing. So de Broglie is in like whatever the Bohr has said. De Broglie is saying that is correct. That's it. Yash, that
So,
is why
but
we are reading it. Yeah.
so in the Bohr model, the electron moves in linear, but it's a wave in the linear
See,
path.
if electron has a wave nature, it will move in a wave form only. But that thing was not given at that time by Bohr. He didn't focus on that particular thing. Now de Broglie is telling about its wave nature and how many waves can come in an orbit. That is given by de Broglie. That is why we are reading this thing in this topic. Yes.
Yes, sir. Got it, sir.
If electron has a wave nature, it will move in a waveform only. But Bohr did not give information that more, more. He did not talk about that particular thing. He said about radius, energy, and all those things. De Broglie talked about the wave nature and the particle nature both together. That is why we are reading this particular thing in topic, this De Broglie topic.
Yes, sir.
Okay.
Yes, sir. Thank you, sir.
Yeah. He's just saying that yes, Bohr was correct. So we will try to find out some combined relationship between the two. Okay. As Sania has asked it, क्या बोर का मॉडल गलत था? बोर का मॉडल गलत नहीं था. According to De Broglie's model was not incorrect. It was correct only. So he found some relationship between the two. That's it. And he has not given his own model also. Okay. Number of waves in an orbit. Number of waves in an orbit is equals to n of that orbit. N is the number of that orbit. Third orbit mein there will be 3 waves. Fourth orbit mein there will be 4 waves. Fifth orbit mein there will be 5 waves. In third orbit there will be 3 waves. Fourth orbit There will be four waves. So question comes, how many waves are present in that particular orbit? Yes, Aradhya. There are other reasons also, but this can also be one of the reasons.
So on
ठीक है,
what
inter
basis
electronic,
it is
yes.
decided that they're equal?
I'll give the derivation of that. Okay.
Okay, sir.
So according to Bohr model, MVR is equals to NH upon 2 pi. MVR is equals to NH upon 2 pi. Any doubt in this? ये बोर का postulate था. And by seeing this, what is the distance traveled in this? इसमें कितना distance travel होगा? Distance traveled in a circular path. Distance traveled in a circular path is 2 pi r. Any doubt in this? Okay. And it is moving in this form. It is moving in this form. So we can say we have n times this lambda. 2 pi r is equals to n times the lambda. From this we can say 2 pi r is equals to n times the lambda, where n is the number of waves. Number of waves. Any doubt in this? N times we have this. We have this. Any doubt in this? Make this your second equation. So we can say number of waves is equals to 2 pi r upon lambda. Any doubt in this? Any doubt in this? Now, lambda is equals to NH upon MV.
Sir, please scroll up.
Just wait. Do it fast. Done.
Yes, sir, done.
Lambda is equals to H upon MV, de Broglie equation. So we can put the value of lambda in this, putting the value of lambda in, let it be A equation. We will get number of waves is equals to 2 pi r upon h upon mv. Any doubt in this? Any doubt in this? Two pi into mvr divided by h. Any doubt in this? MVR is what? MVR, putting the value of MVR from first equation. MVR is equals to NH upon 2 pi, where N is the orbit. So it becomes 2 pi into NH upon 2 pi into h. So h and h will get cancelled out. 2 pi get cancelled out. It becomes n, which is the orbit. Now see this derivation from the starting. Sanika understood.
Yes, sir, got it.
This is how number of waves in an orbit is equals to the nth value of that orbit.
So can you explain again the last part?
Last part. See, number of waves is 2 pi r into h upon mv. I have kept the value of lambda. Then I splitted them. This becomes mvr. So I kept it together like separately mvr, and this is 2 pi. MVR is equals to NH upon 2 pi from the Bohr model.
Yes, sir.
So we can put that value MVR is equals to NH upon 2 pi.
Okay, sir, understood.
So 2 pi will get cancelled out, H will get cancelled out, we'll be left with N, where N is the orbit.
Okay, sir, understood.
Okay,
Yes, sir.
so number of waves in an in the nth orbit is equals to N of that orbit. थर्ड वेव के अंदर 3 वेव्स, फोर्थ ऑर्बिट के अंदर 4 वेव्स, 5 के अंदर, फिफ्थ ऑर्बिट के अंदर 5 वेव्स. दैट इट विल बी. All of you understood this? All of you understood this?
Yes.
Any problem to anyone? I don't know. Heisenberg uncertainty principle. Heisenberg uncertainty principle. According to it, the exact position and velocity of electron in an atom cannot be calculated simultaneously. Simultaneously. According to it, the exact position and velocity of an electron in an atom cannot be calculated simultaneously. Copy it fast. All of you have copied it.
So no, sir.
Yes, sir.
For example, this is the nucleus, and here somewhere we have electron. If you try to locate this electron, it is a microscopic particle. It is a microscopic particle. You cannot locate it with the naked eyes. You have to use microscope kind of thing. You have to use some microscope kind of thing to locate it. Without that, it won't be possible. Okay. To locate the electron, you have to use high resolution microscope. Right? So if you want to find out the exact position of electron, you have to use a high resolution microscope. But the energy that you are passing will be taken up by the electron, and will get dislocated. Will get dislocated. Will get dislocated. If you do not use this microscope, you won't be able to see it. So all the time there will be some error in the position. There will always be the error in the position and the velocity of electron. If you do not use microscope, then there will be a error. If you use microscope, then one thing will become certain, other will become uncertain. That is why you cannot predict the exact position and the momentum of electron simultaneously. All of you understood this?
Sir,
Yes.
what have you written? H upon 4 pi?
Yes. H upon 4 pi. Rest everything you understood? Rest everything you understood? What
Yes,
about
sir.
others?
Yes, sir.
We cannot find out the exact position and the velocity of electron simultaneously. If we try to locate it with microscope, we will be providing energy to the electron, it will get dislocated. If we do not use this microscope, we won't be able to find it out only and where this electron is kept. So there will always be some error. Okay, this is called error in position. Error in position. This is delta P. This is error in momentum. Error in momentum.
So what is that after delta x? Is there a dot?
Dot multiplication.
So,
Amod. When you provide energy to it, the energy will increase also, na? And that increased energy will be reflected in the form of velocity only. The extra energy will be reflected in the form of velocity only. As we have done in the photoelectric effect, all extra energy became the kinetic energy of electron. Same thing is here. Amod, understood? Velocity will remain constant unless and until you apply some external source to it. Velocity will remain constant unless and until you apply some external source to it. जब तक नहीं लगाओगे तब तक velocity सेम रहेगी. जैसे ही लगाओगे वो velocity change हो जाएगी. So I can say delta x dot delta p is equals to a constant, is equals to a constant. That means if delta x increases, delta p will decrease. When delta x becomes 0, delta p will become infinite. Any doubt in this? And
No, sir.
vice versa? Any doubt in this?
Sir,
Yes.
so can you explain it again?
Which one? Which part?
Just now you said how it increases and decreases.
If two things are, see, if I take 10 into 1 equal to 10, right? Sania,
Right, sir.
I can also write it like this.
Yes.
I can also write it like this. I can also write it like this. I can also write it like this. Sanya.
Yes, sir.
So when a into b is equals to constant, जब a into b equal to constant होता है, one value keep on decreasing and one value will keep on increasing.
No, sir. Didn't understand.
See, let this be a, let this be b, right? A into b is equals to 10 है. Now, if this value remains constant and one of the value is decreasing, ये 10 से 5 हो गया, then this will increase from 1 to 2. Then only it will remain constant.
Got it, sir.
Okay, इसको
Yes,
और
sir.
decrease करो 5 से 2. This will more increase from 2 to 5. इसको और decrease करो 2 से 1. This will become 5 to 10. इसको और decrease करो 0.1. This will become 100. If you
I got it, sir.
want your right hand side to be same, then one should increase and one should decrease.
Got it, sir. Thank you.
Okay. इसीलिए हमने बोल दिया कि अगर ये 0 हो जाता है, ये इनफिनाइट हो जाएगा. All of you understood this? So delta x dot delta p is equals to h upon 4 pi. This is Heisenberg uncertainty principle. It can also be written as ये मैथ्स कॉपी नहीं करना है.
Yes, sir.
But
Thank
x
you.
cannot be 0. Sir, but delta x cannot be 0, no, because on right hand side we have a constant. I have just said if you become more certain about position, you will become more uncertain about velocity. Yes, it is just tending to 0. डेफिनेटली अगर 0 हो गया मतलब हम उसको हमें पता चल गया इलेक्ट्रॉन कहाँ प्रेजेंट है, वो तो पॉसिबल नहीं है. प्रणिल, इंस्टेड ऑफ अपोजिट से इनवर्सली प्रोपोर्शनल. प्रणिल, instead of saying opposite say inversely proportional. अपोजिट तो यार इंग्लिश का वर्ड है. इनवर्सली प्रोपोर्शनल का मतलब एक इंक्रीज करेगा एक डिक्रीज करेगा. I can write like this also.
So it means that the more we are confident about the speed, the less confident we can be about the position.
Exactly. This is how you have to think. ऐसे ही सोचना है आपको. हम जितना ज्यादा श्योर हो जाएंगे हाँ यहाँ पर इलेक्ट्रॉन है, उतना ही ज्यादा we do not know what is its velocity. And if
Okay,
we are
sir.
100% know कि वो 10⁻⁻7 से चल रहा है, then we do not know what is its position. The more we are sure about its position, the lesser we are sure about its velocity. Both cannot be determined exactly with certainty.
Yes, sir.
Okay. Very good. So this can be written as delta x dot delta v is equals to h upon 4 pi m. Any doubt in these two? इधर उसमें ना m नीचे रख दिया, that's it. अगर हम क्वेश्चन देखें, if the change in position and change in momentum are equal, then change in velocity will be expression you have to tell, not the value.
So just scroll up a bit. Yes, sir. Thank you.
From Heisenberg uncertainty principle, delta x dot delta p is equals to h upon 4 pi. According to question, delta x is equals to delta p. So it becomes delta p into delta p is equals to h upon 4 pi. And delta p square is equals to h upon 4 pi. M square delta v square
Can you please
is
scroll up?
equals to h upon 4 pi.
Done, sir.
So delta v square is equals to h upon 4 pi m square. So delta v is equals to 2m h upon pi root. Understood? Just wait a second. तुझे नमस्ते भैया मैं क्लास में बैठा हूँ पर हमने कॉल करना ठीक है नमस्ते all of you understood this. Okay, now if we take another form of Heisenberg uncertainty principle, do we know kinetic energy of electron is also equals to energy of electron. Equal in magnitude, opposite in sign. Do we know this? And kinetic energy is equals to half mv square. We can say energy is half mv square. Any doubt till here? Any doubt in this?
No, sir.
If we multiply both sides by m, it becomes half m square v square is e into m. Or we can say 2em is equals to p square. Any doubt in this? So it also means p square upon 2m is equals to energy. Any doubt in this?
So can you please scroll up? It done.
If we differentiate this, differentiate with respect to p. If we differentiate with respect to p, it will become dE by dP is equals to 2p by 2m. Do we know differentiation of p square is 2p? Do we know differentiation of p square is 2p?
Yes, sir.
Do all of us know
Yes,
this?
sir. Yes, sir.
Okay. तो ये हो गया p by m and p by m will be v. Any doubt in this? V means dx by dt, change in velocity per unit time. That means dE by dP is dx by dt. Any doubt in this? Any doubt? That means dx dot dp is equals to de dot dt. So, as we know that delta x dot delta p is equals to h upon 4 pi, it should also be equals to delta E dot delta T. So this is also the Heisenberg equation. This is also the Heisenberg equation, as this is the Heisenberg equation. Now read it from starting. If there is any doubt, you can ask. How dx dot dp is equals to de dot dt. ये क्वेश्चन आया हुआ है वर्ष 2017 में. Is this also the Heisenberg equation? The right one. 2017 NEET. The right one. Is this also the Heisenberg equation? So we have proved it. Understood?
Sir,
Yes.
questioned. No, which one you said was questioned in
The
2017?
question was delta E dot delta T is equals to h upon 4 pi. Is this also the Heisenberg equation? That was the question.
Okay, sir.
Yeah. All of you understood the full derivation? All of you understood the full derivation? Any problem to anyone in this?
No, sir.
Okay. If we have a question like find uncertainty in velocity of particle in a distance of 0.1 angstrom. Consider that particle is electron. So for such questions, we do not have to do anything. Just put the formula, you'll get the answer. Delta x dot delta p is equals to h upon 4 pi. Delta v is required. So delta v will be h upon 4 pi m into delta x. All values you know, 6.6 into 10 to the raised power minus 34. 4 pi m and 0.1 into 10 to the raised power minus 10. Solve this, you will get the answer. Very simple question comes from this because they are formula based. All will be formula based. Okay. So he said that Bohr model is incorrect. De Broglie ने नहीं बोला था. Heisenberg uncertainty principle proves that Bohr model is incorrect because Bohr model said that we can identify what is the radius, what is the velocity, everything we can find out. ठीक है, हाइजेनबर्ग
Sir,
ने बोल
can
दिया it is. Yes.
Sir, can you explain it again? I didn't understand.
That form, that numerical,
Yeah.
it is uncertainty in velocity we have to find out. Okay.
No,
So
sir,
we'll
not that.
write down.
What you have just said.
Then I have said that Heisenberg uncertainty principle proved Bohr model wrong, because Bohr was saying that we can find out the exact position of electron. He know the radius, he know the velocity. Then we can, according to Bohr model, we can easily find out where that electron is present. But what he said it is not possible only to find out the exact position of electron. Getting it?
Yes, sir.
फॉर एग्जाम्पल आपके पास एक पाथ है, राइट, दिस इज द पाथ। ये पाथ है कितने का, 10 किलोमीटर का। यहाँ पर आप हो, एंड वी नो योर वेलोसिटी आल्सो, यू आर मूविंग विद 2 किलोमीटर पर सेकंड और फिर 2 किलोमीटर पर आवर। If we know the path, we know the velocity, we can tell at what point where what will be your position. Bohr said gave the distance, gave the velocity. That means according to Bohr, we can find out the exact position of electron, right? अगर आपको distance पता है, velocity पता है, you can simply say where that electron will be present. But what Heisenberg said, that it is not possible to find out the exact position of electron. Hence, Bohr model was wrong, and Heisenberg gave new theory, which was your quantum number.
Understood, sir.
Heard the last line. इस तरह से बोहर की थ्योरी गलत हो गई, और हाइजेनबर्ग सेड इट इज नॉट फाइंड आउट टू, इट इज नॉट पॉसिबल टू फाइंड आउट द एग्जैक्ट पोजीशन ऑफ इलेक्ट्रॉन, एंड देन ऑर्बिटल came, the possibility, the probability of finding an electron came, which was your quantum number. All of you understood the last line?
Yes, sir.
Heisenberg proved it is not possible to find out the exact position of electron. We can only rely on the probability of finding an electron. और उस probability के ऊपर पूरा quantum number based है, जो हमने पहले ही पढ़ लिया.
So Bohr's theory was wrong.
Yes, he proved Bohr theory was wrong.
Okay.
Okay, I am again repeating the last line. Heisenberg said it is not possible to find out the exact position of electron. Hence, Bohr theory is wrong. Then what does he said? He said we can find out the probability of finding an electron. कहाँ पर इलेक्ट्रॉन मिल सकता है, that we can find out. और उसके ऊपर पूरा क्वांटम नंबर बेस्ड है. Yes.
So what is the use of finding the position of an electron? Even if we
With the
did
use, we
Yes,
will
sir.
do the whole chemistry on that basis only. आगे आप next chapter से देखोगे, if we do not know the position of electron, we cannot do anything. Next chapter से आपको पता चल जाएगा कि position of electron is the basic of all chemical reactions and everything. अगर आपको ये नहीं पता है कि इलेक्ट्रॉन कहाँ प्रेजेंट है, you cannot do anything. Is it towards the nucleus, away from the nucleus, कौन से shell में present है, wherever it is present. If you do not know it, we cannot do the chemistry only.
Sir,
Radhe, understood?
Yes,
इसीलिए
sir.
I said कि quantum number is the basics of chemistry. जितना आपको quantum number आता है, you can easily move to the third chapter. If you know the third chapter, you can move to the fourth chapter. Second chapter का quantum number, third chapter and fourth chapter are linked. If you do not know the quantum number, you cannot go into all those topics. If you do not know the third chapter, you cannot read the chemistry. तो वो सब इसी पर बेस्ड है कि इलेक्ट्रॉन प्रेजेंट कहां पर है, उसके ऊपर ही सब कुछ बनाया गया है. ओके, इसलिए आई सेड 95% प्रोबेबिलिटी. या यस, एनीवन एल्स?
sir,
यस.
that means quantum number tells us the exact position of electron.
नो, 95% प्रोबेबिलिटी के साथ, एंड वी अज्यूम इट टू बी एग्जैक्ट.
Okay, sir.
हम उसको एग्जैक्ट मान के ही बाकी की सारी केमिस्ट्री पढ़ेंगे. बट Heisenberg itself said it is not possible to find out the exact position of electron. So how can he give the exact position? Okay, as I said, मैंने आराध्य को एक बार एग्जांपल दिया था. See, if we have a balloon, okay, if we have a balloon जो कि भरा हुआ, right? We have a we have a balloon and we put one inside into it, insect into it. If this is the balloon and we put an insect into it, then we know that insect is present inside the balloon. It is moving, but we do not know its exact position. So that balloon is basically the orbital, where we know that 95% we know that electron is present at that particular place only, but exact position we do not know. Understood?
Understood, sir.
Any other problem to anyone?
Excuse me, sir.
Yes.
So if according to Heisenberg's uncertainty principle, like if both the change in momentum and change in position, if they are equal, then will it still hold?
What do you mean by that?
Means
Yeah,
will it
if
still be
something is increasing, if something is increasing, something is decreasing, at one time they will become same also.
yes,
It's
sir.
like an equilibrium thing. Something is decreasing, something is increasing. At one time they will become same. There may be a condition. And that was just a question, a hypothetical question based on that.
Okay, sir.
ठीक है, फॉर्मूले के ऊपर क्वेश्चन बनाया गया है. That's it. It's not like the real thing.
Okay, sir.
All of you understood? So we'll take maximum of 5 minutes of the next class and then we'll move to the third chapter. That's it for today, okay?
So what part of this chapter is left?
Just I'll give you in details. I'll dictate all these things, what Heisenberg said and what did he give. Very less,
Okay, sir.
around 5 to 10 minutes. Right?
Okay.
जो मैंने बोला है, मैं लिखवा दूंगा थोड़ा सा. That's it.
What is
What?
the next chapter? Thank you, sir.
Periodic classification. Periodic classification. Okay.
Thank you, sir.
Okay, sir. Thank you, sir.
Thank you, sir.
Please
Thank you,
read
sir.
this
Thank you, sir.
chapter again.
Thank you, sir. Happy Teachers Day, sir.
Thank you.
Yes, sir.